This is section 10.7, volume of pyramids and cones. These are the objectives: learn and apply the formula for the volume of a pyramid, learn and apply the formula for the volume of a cone. No vocabulary. Next slide. Here's the first formula. You can notice that they look very similar to what you have done in the past. The only thing that is going to change is this number here, 1/3. The volume of a pyramid with base area B and height h is equal to whatever the area of the base is, so whatever this area is, times the height, and divided by 3 or multiplied by 1/3. And that's basically it. This is how you compute the volume of a pyramid. Let's go to the next slide. Apply this formula. Just find the volume of the square pyramid with base edge length 9 centimeters and height of 14 centimeters. So notice that the area of the base is 81, and keep in mind that they're giving you that the height is 14. They don't give you that information in the picture, but you know the height is 14. Apply the formula: 1/3 times the area of the base times the height. This is the area of the base. The height is 14. Excuse me. Simplify this. You get 378 cubic centimeters. Number 2. Says find the volume of a regular hexagonal pyramid with height equal to the apothem of the base, with the height equal to the apothem of the base. So first thing, keep in mind that the apothem is 6 radical 3 feet. How do I get this? You just have to go through the steps that you learned in chapter 9. Have half the center angle. This is 6. You have your 30/60. You multiply this by the short leg times radical 3 to get the long leg, and that's your apothem. And then notice that your height is also equal to the height equal to the apothem. So now that you have this information, we're going to compute the area of the base. The area of the base is 1/2 a apothem times p, which is the perimeter, and you end up with whatever this is, 216 square root of 3, or radical 3. And then you need to use the base area and the height to find the volume. So this is where you apply the formula: 1/3 times the area of the base times the height. The height is 6 radical 3. This is the area of the base. Simplify this, and you end up with 1,296 cubic feet. Let's go to number 3. Now this is a different formula for a cone, but you're going to notice it's not too different. So to find the volume of a cone with base area B and radius R and height h is equal to 1/3 the area of the base times the height. So whatever this is, the area of this base, but you know that this is a circle, that's why you see pi r squared, and then times the height, and then divided by 3 or multiplied by 1/3. Let's go to the next slide and apply this. It says find the volume of a cone with base circumference 25 pi inches and height 2 inches more than twice the radius. Round your answer to the nearest tenth. Here they don't give you a picture, they just give you the following information, and you're going to have to find the missing information to find the actual volume of this cone. So we use the circumference to find the radius, because they're telling you that the circumference is equal to 25 pi inches, or just 25 pi. So 2 pi r equals 25 pi. Solve for r, you get 12.5. Now that you know the r, we're able to find the height, because the height is 2 inches more than twice the radius. That's why we have this expression. So the height is 27 inches. I forgot the inches here. And then at this point, we have enough information to actually find the volume of this cone. which is 1/3 pi times the radius, 12.5, times the height, which is 27. Simplify, you get the following. If you round to the nearest tenth, this is your answer. 4,417.9 cubic inches. Next slide. Find the volume of a cone, round to the nearest tenths. So this is the information in problem number 4. The radius, the slant height, you don't have the height. So we need to use the Pythagorean theorem to find h. Once you apply the Pythagorean theorem, this is the equation that you set up, and you end up with h equals 30. Step 2 is to find the volume. You know the radius, you know the height. Apply the formula. Substitute. Simplify. And here we need to round to the nearest tenths, so you multiply the pi. 8,042.5 cubic centimeters. Let's go to the next slide. This is exploring the effects of changing dimensions. Says the diameter and height of the coin are divided by 3. Describe the effect on the volume. Since we're talking about volume, you should know that you're going to use this number and you're going to raise it to the 3rd power. That's why the answer to number 5 is what you see there. Since we're dividing, this is the answer. Divided by 3 cubed or by 27. Next slide. Same idea, exploring effects. Here, now we're looking at doubled. If you remember, double represents the number 2. So we're going to take this number and we are going to cube it. That's why the answer to number 6 is multiply by 2 cubed or by 8. That's simple. Just go to number 7. It says find the volume of the composite figure. Round your answer to the nearest tenth. So you have the following information here. Notice that from here to here is 35. From here to here is 40. So this is the height of this bottom cone, 40. The height of this cylinder is 35. They don't give you this information. But the whole thing from here to here is 70. That's why this is 35. Because this is 35. So let's go ahead and find the volume of the upper cone. You have the height, you have the radius. You get the following. Now let's find the volume of the cylinder. So you have the radius, you have the height. Is the following. And then now we're going to find the volume of the lower cone. You have the radius and then the height, 40. And now that you have these 3 answers, these 3 volumes, the total volume of the composite figure is by adding these, and then you round at the end to the nearest tenths, and this is what you get. Problem number 8 is the last problem on this video. So here we go. Now we're going to find the volume of this composite figure. Notice that you have a rectangular prism and then you have a pyramid that is missing from the inside of the rectangular prism. So we're going to find the volume of the rectangular prism, length, width, and height, and you end up with 4,500 cubic feet. Now we're going to find the volume of the pyramid, and basically it's the same idea as what you see here. I mean, you're going to be using the same dimensions, but now you're going to divide this by 3 or multiply by 1/3. That's why you see this. 1/3 in the same dimensions, and it's 1,500. Now at this point, all you're going to do is to actually find the volume of the composite. You're going to take these 2, and you're not going to add them. You're actually going to subtract them because the pyramid is missing from the inside of the rectangular prism. And you end up with 3,000 cubic feet. And this concludes the video.